All right, so I'm going to make a video for all of the factoring problems, so all 25. It's going to be a pretty long few videos, I think, but I'm going to try and break it up into a few separate ones. These videos will not be locked, so you can fast forward to any question you want, and I'm going to go through in order. So we're going to start with question number 1. All right, so the first thing we need to do is we need to rearrange these so that we're in descending order. So we need to go negative x squared plus 6x minus 9. Right? Then remember I said that this x squared has to be positive, so we're going to factor out a negative 1. And when we factor out a negative 1, all of our signs change, so it changes to x squared minus 6x plus 9. Right? Now remember, the first thing I said that you should look for whenever you have a trinomial is our first term and our third term, after we put it in descending order, positive? Yes, they are. Then we see, can I take the square root of each? Well, the square root of x squared is x, the square root of 9 is 3. Then we multiply them together. That gives us 3x. Then we double it. And after we double it, if it matches this middle term, disregard the sign, then we know it is a perfect trinomial square. And our answer is we write a binomial with a square. We put our two square roots, x and 3. Whatever sign we have in front of our middle term is the sign that goes here. And then we can't forget the negative 1 out front. So this is our answer. I'll show you how you can use the x method real quick. So we draw our x, we write the multiplication, we write the addition. We multiply our first number and our third number, so 1 times 9 is 9. The middle number drops to the middle. So numbers, if they multiply to be positive and are adding up to negative, that means they both have to be negative. It's the only way that they can multiply to positive and add to a negative. And numbers that multiply to 9 and add to 6 are 3 and 3. Then we divide each one by the number in front of our x squared, or 1. And remember, we start from the bottom, so that tells us what gets multiplied to the x. And now we're here, so it's 1x minus 3, 1x minus 3. And then we can't forget the negative 1 out front. All right, so either way, no matter what method you use, you'd still get the right answer. Both of these are correct. All right, going forward, if it is a perfect trinomial square, I will not use the x method. I will just use this method. All right, I'm going to try and go through these as quickly as possible. All right, so now, remember, anytime we have a problem, the first thing we're looking for is to rearrange and take out a negative if possible, and also to take out our GCF. And all of these are even numbers, so I know that they're all at least divisible by 2. So I need to make this positive, so I need to take out a negative, and I need to take out our GCF, which is 2. And when we divide each one by negative 2, well, this divided by negative 2 just gives me positive x squared. This divided by negative 2 is minus 2x. And this divided by negative 2 is minus 63. All right, then, since this is a negative sign, we can't do perfect trinomial squares, so we're going to draw our x. This is our multiplication. This is our addition. So we multiply our 1 times our negative 63. And then this middle number, this drops, so it's going to be negative 2. All right, now, if they multiply to give me a negative number, I know one of them has to be positive and one of them has to be negative. So numbers that multiply to 63 and have a difference of 2, well, that's 9 and 7. And then now they need to subtract or add to give me a negative 2. So that means our larger number has to be negative. So it will be positive 7 and negative 9. Since this number is a 1, we're going to divide each one by 1. So we started from the bottom, so it's 1x plus 7. And now we're here, so we started from the bottom, now the whole class here. So 1x minus 9, and our GCF gets written out front. All right, so here we have a trinomial, and they're both positive, so we can look and see, can I take the square root of 90? Well, the square root of 90 is not a perfect square, so we're not going to be able to use a perfect trinomial square for this one either. So we draw our x, we write our multiplication sign, our addition, we multiply our 1 times our 90, so it gives me a 90. The negative 19 drops, so it's minus 19. Once again, if they multiply to a positive number and they add up to negative, that means they both have to be negative. Numbers that multiply to 90 and add up to 19 are 10 and 9. And now we need to divide by that a. So that was 1, so we're going to divide each one by 1. And now our factored form is we start from the bottom, so it's 1x. And then we subtract the numerator or denominator or add it, so it's 1x minus 10 and 1x minus 9. Started from the bottom, now we're here. All right, so for this one, remember, we rearrange if we can, but then we also need to look for a GCF. And 4 is divisible into both 20 and 96, so I'm going to factor out that 4. And when I factor out the 4, I'm left with k squared plus 5k minus 24. Since this is a negative sign, we know it cannot be a perfect trinomial square, so we don't even have to look for the square roots. So we'll draw our x. We draw our x method, our plus method. So then it's 1 times negative 24, so it's minus 24. This middle number just drops. If numbers multiply to a negative, I know they have to be a positive and a negative. So what are numbers that multiply to negative 24 and have a difference of 5? That is going to give us 8 and 3. And now they need to be a positive 5. So that means 8 needs to be positive and 3 needs to be negative. And remember, check your work. 8 times negative 3 is negative 24. 8 plus negative 3 is positive 5. Now we need to divide by the number in front of our x squared or k squared. So we're going to divide by 1. So then we start from the bottom. So it's 1k plus 8. And then we start from the bottom. So it's 1k minus 3. And then this 4 is going to drop down. Remember, you can't forget about the 4. I made a mistake for this one. I'm going through these really quick. I'm going through these too quickly. On your test, just make sure that you are not going through as quickly as I am, because this should be 1b and 1b instead of 1x. All right, so just make sure that you're not going through these. I'm kind of rushing through these so that the videos aren't that long. All right, so for this one, same thing. First thing we're going to do is we're going to factor out our GCF. Well, all of these are divisible by 3, so I'm going to factor out a 3. Now I'm left with 2x squared minus 15x plus 7. All right, so 2 and 7 are not perfect squares, so we're not going to be able to do our perfect trinomial square method, but that's what we're always looking for first. We draw our x then, we write our multiplication, we write our addition. 2 times 7 is 14. The negative 15 just drops. So numbers that multiply to positive and add to negative, we know that means that they're both going to be negative. And numbers that multiply to 14 and add to 15 are going to be negative 14 and negative 1. Check your work. Negative 14 times negative 1 is positive 14. Negative 14 plus negative 1 is negative 15. Now we need to go ahead and divide by the number in front of our x squared. So we will divide each one by 2. And remember, you need to reduce. So this negative 14 over 2 is actually equal to negative 7 over 1. You would never leave your fraction not reduced. So now after we reduce it, this tells us our factored form. So we start from the bottom. So it's 1x minus 7. We start from the bottom. So it's 2x minus 1. And then we don't forget our GCF. That needs to go out front. All right. And if you have time on your test, you can multiply all these through, and you must get back to your original problem for you to know if you did it right or wrong. All right. So for this problem, same thing. 12 is not a perfect square. So we know that we cannot use the perfect trinomial square method. So we're looking for a GCF as well. They're all even. So I know I can at least factor out a 2. So when I have to factor out a 2 from all of these, I'm left with 8m squared plus 19m plus 6. All right, now 8 and 6 are not perfect squares, so we can't use a perfect trinomial for this one either. So we're going to go ahead and draw our x, write our multiplication sign, our addition sign. 8 times 6 is 48, and then this middle number just drops, so it's 19. So now if they're going to multiply to a positive and add up to a positive, that means both of these signs have to be positive. Numbers that multiply to 48 and add to 19 are 16 and 3. So remember, after we find this part, we multiplied by 8 to get to this 48. So we need to divide by that number. So each of these, make sure you're dividing by that number in front of the x squared, or whatever m squared in this case. So then 16 over 8 reduces to 2 over 1. So we don't need to worry about that one anymore. So remember, we start from the bottom. So it's going to be 1m plus 2. And now we're here. So we start from the bottom, and now we're here. So it is 8m plus 3, and then this number in front, the 2, gets written out in front as well. All right, you cannot forget your GCF. All right, so since this is a negative number, we cannot use our perfect trinomial square, so we're just going to go ahead and get started with the x method. We multiply the 1 and the negative 70, that gives me negative 70. The negative 3 just drops, so it's minus 3. Since this is negative, we know that our two signs have to be positive and negative. So then numbers that multiply to negative 70 and have a difference of 3, that is going to be 10 and 7. All right, so now which one has to be positive and which one has to be negative? Well, since this number is negative, the larger number must be negative. So it'll be negative 10 and positive 7. So then check our work. 7 times negative 10 is negative 70. Negative 10 plus 7 is negative 3. Now we're going to divide each one by the number in front of the x squared. So then that tells us our factored form. We start from the bottom, now we're here. So it's 1x plus 7. We started from the bottom, now we're here. So it's 1x minus 10. And that is it for this problem. All right, so once we see 4 terms, we know we're going to factor by grouping. First, we look for a GCF, though, which there is none. Then we're going to group our first 2 terms together, And remember, if they're not in order, you must rearrange them. But we're going to put our first two terms together. We always add in between, and whatever sign this is follows our number. So it is still positive 42a plus 12. Then we factor each of these groupings out. Well, here, I'm sorry, this should have been 2a squared, not 2a cubed. Here we can factor out an a squared, so we're left with 7a plus 2. And now we know that this first binomial needs to go to 7, so we can think about, what do I need to factor out of 42 to get to 7? Or we can look for the GCF. But we know here 6 goes into both 12 and 42, so I'm going to factor out a 6, and I'm left with 7a plus 2. Right? Now that we know that these two are exactly the same, that means we can combine these two factors together in one binomial. So it's a squared plus 6, and then it's multiplied by 7a plus 2. Because if we were to go ahead and multiply this and we distribute the a squared in, we would get a squared times 7a plus 2. And then when we distribute the 6, it'll be plus 6 times 7a plus 2. So it's the same thing as we had here. So we only need to rewrite this one time. Right, that is going to be it for this video. We're approaching over 10 minutes, so I'm just going to create a new one now.